All right. Welcome to the next latest and greatest webinar on CIS-211, Principles of Computer Programming 2 here at Georgia Military College. I am Professor Lusby, and I wanted to create another weekly webinar recording here going over what it is that we need to do for week 2. All right, so we are into the second week of the course, and in case you've missed previous webinars, I have posted them at the top of the classroom. For sure, check those out. I assume everybody's pretty much familiar with the classroom by now, and you know where all the important links are, so I'm not going to go over those again. The only one that I am going to point out here is this wonderful handy-dandy virtual desktop that has everything you need installed already, including a Java IDE, JDK, JavaFX, and all of that good stuff. All right, with that said, and I'll demonstrate how to use that virtual desktop here in just a second concerning week 2. All right, so what the heck is week 2 all about? Week 2 is concerning chapter 10 of your book, and chapter 10 is basically about inheritance, polymorphism, maybe a little bit of abstraction, okay? And that's what we're trying to learn about this week. It's good. We're finally getting into good object-oriented design, all right? And so for sure, read chapter 10 here in your book. It talks about those three things, right? Inheritance, polymorphism, and interfaces, which we can create with abstract classes. And there is a lot of good examples in here. At a high level, it talks about inheritance, and that basically gives us a way to create a hierarchical type of design where you have a parent class, okay, or I guess a super class, and then you can always have objects that inherit from whatever, I call it a base class, right? Where you can inherit from the base class, and for instance, this application class here would get all of the good stuff from its parent or base class called object. Even down here, if you created this class called draw sprite and you inherit from application, well, you get all the good stuff from the base from this class, the base class called application. You inherit all of its capabilities, including the objects as well. So it's a very it's an object-oriented way to group your classes into hierarchies or subclasses and superclasses. All right. There is some good examples of this using code, I believe. Well, here's a UML diagram describing what inheritance is at a high level. Industry would expect you to be able to look at a class diagram like this and understand it. The way we know that inheritance is going on is there's this little triangle guy that always appears at whoever the base class is or whoever the parent class is. You put the triangle on the base class, and then it extends the base class. So we can see that bank account inherits from object and checking account inherits from bank account. All right. So yeah, definitely look that over. And what we'll see in code is that when we use this inheritance design, initially you call out the base class. In this case, it is, let's say, called bank account. All right. And then you are able to extend whatever that base class is inside of a new class that maybe has more specialized behavior than the old base class. All right. And so this extends keyword is definitely important. It allows us to inherit from whatever our base or parent class is. Now, when we inherit, that's where these public, protected, and private keywords are important because even if the checking account extends bank account, it does not have access to any private member variables inside a bank account. It only has access, the specialization class that extends bank account only has access uh, to the public methods, as well as the public or protected uh, member variables declared at the top. Um, so keep that in mind, that we still have to decide when we're creating classes whether to create uh, the member variables or the methods as public, protected, or private. And in fact, some languages don't even implement protected, because protected does kind of uh, break the rules of encapsulation, where each class should not expose its member variables. Um, and so normally you have to decide between public or private. And then it gives us some nice why we would do these things, depending on which one that you want. Public member. When I say member variables, I mean fields, and the methods are the actual functions themselves that are inside of the class. All right, so high level, that's what's going on with inheritance. Here they talk a little bit more about protected, and how you can use protected with a member variable or field. They give some good examples there. What else? What else? What else? Here's the abstract classes, where an abstract class basically means that uh, you have a base class that is mostly implemented, but there are a couple of abstract methods that are not implemented. For example, figure is a base class. Well, object is a base class. Figure inherits from object, but the reason why figure is an abstract base class is because if you look down here, you see how this draw method is in italics. That basically means that this class has defined all of these member variables and methods except for this one. And the figure base class is going to call this draw method out as abstract. Why does that matter? Because if you have another specialization class that extends figure, all right, this figure abstract base class, it has to implement this draw method. So that's why you see circle has a draw method that's been implemented. How do we know that? Well, it's not in italics. We also see this square class that is inherited from figure, and it has also implemented this draw method. All right, so abstract classes, whatever is declared as abstract inside of the abstract class, has to be defined by the specialization classes that inherit from it. All right, so that's what abstract means. And in order to do polymorphism, which is what they talk about next, polymorphism, yeah, you need this kind of setup, because at some point, you've got a bunch of like classes that are all, for instance, they all inherit from this figure base class. If we use polymorphism, as long as we know that each one of these objects is a figure, well, then we can just call this draw method, and we don't care if it's a circle or a square, because everything that inherits from figure has to have this draw method. So we have a way of grouping all of these specialization classes that are underneath a figure, and we just know, well, all of them have draw. So if we store all of these specialization objects in, let's say, a list or an array list, we can just cycle through all those specialization objects and call draw for all of them. We don't care if it's a circle, we don't care if it's a square, we don't care if it's whatever shape that is being specialized with this figure class. All right, so definitely get to know what abstract means. And in code, do they show us an example? Yeah, here's figure, and notice that here, that draw method is called out as abstract. It has a semicolon at the end, right? It does not, like all the rest of these methods above it, are not abstract, and you do have to use the curly brackets. You do have to define what each one of these methods will do. But when you call it out as abstract and your class is abstract, you're saying, hey, the child or specialization class is going to implement this later. All right. The other side effect that this has concerning abstract is that you can't create a figure object directly because there's abstract methods in here that need to be implemented before you can create an object with it. So these abstract classes are nice when you kind of have a common theme uh, between all these specialization classes. You can declare this as abstract and ensure that everybody that inherits from this abstract class has the same kind of API, has the same abstract methods uh, that you can use. And when you do that, obviously you have to put the abstract keyword at the top when you're declaring the base class, and you have to put the abstract keyword on any of the abstract methods inside of that abstract class. All right. Polymorphism takes advantage of these wonderful abstract classes. And for instance, here, remember we had that class called figure. And here they're creating an array list of all these different figures, right? And notice that each one of these figures can be a square, right? A square object or a circle object. All right, and we can add, it doesn't matter if it's a square or circle object, we can add it to this figure list array because underneath of each one of these, they all have the figure abstract base class underneath. So here's where polymorphism comes in, right? So we can create all these different figure specialization objects like squares and circles. We can add them to the same array. And then down here, when we create an enhanced for loop and we're going through, right, that entire figures list, we don't care if it's a square or a circle. We know it's definitely a figure because both squares and circles inherit from figure. And we can just call the draw method for each one of these figures. So here, polymorphism is smart enough to look at this draw and know it's a figure, but it knows that draw has to be implemented by one of these specialization classes, and it will correctly call draw inside the circle class if it's a circle object, and it will correctly call draw inside the square class if it's a square object. So it's polymorphism using these abstract classes allows you to take advantage of polymorphism and let the computer figure out, well, which draw are you calling? It's smart enough to see, well, this is a square object, so I'm going to call this square draw method. This is a circle object, so I'm going to call this circle draw method. And we don't have to store, an array list of circles, an array list of squares, and have separate code for the different squares and circles. We can just say, hey, these are all figures. No matter what, go through the array list of figures and call all of their draw methods. This comes in very handy, especially for game development. You're going to see a lot of common abstract base classes being used, and you can always build on top of, right, each one of those abstract base classes, and then implement whatever those abstract methods are that are missing. All right. So at a high level, I just wanted to kind of point that out real quick. That's what inheritance is all about. That's what abstract classes and polymorphism is about. And so, all right, that's what Chapter 10 is about. Make sure that you read over those examples in Chapter 10, definitely before taking the quiz. Okay, so high level, it's over Chapter 10. I kind of went over what is inside of Chapter 10. There are PowerPoint slides here if you want to use those to help you study for the quiz as well. A lot of students find this useful. All right. All right, what's the nitty gritty? What exactly do we need to do for week 2? What is graded? As usual, we have a discussion forum, we have a programming assignment, and we have a quiz. Let's talk about each one of these individually. Let's start with the discussion, and a lot of you have already started this, and that is great news. They want us to complete programming activity 1 using inheritance from the textbook. All right, and we're going to see this a lot in this course, where the discussions have us complete kind of a pre-made programming activity. And so once, at least make an attempt at this. If you can find a solution, great. You're sitting pretty for the programming assignment. But if not, answer these questions to the best of your ability, and for sure, answering these 6 questions, you should have no problem coming up with 150 words. All right, so how do we go about at least attempting or trying to complete Chapter 10, Programming Activity 1? Well, let's take a look at it in our book first and see what it is exactly they want us to do. That's here in 10.4, Programming Activity 1. And yeah, they're kind of staying focused on this bank account example that they go through in the textbook. And it looks like what they want us to do here is create or implement some missing methods in the savings account class, which inherits directly from the bank account class. All right. So if we look at the code inside of this programming activity, and we'll do that in a second. We'll import this code and go over it. We're going to see that there is a savings account.java class, which .java file, which implies that there's a savings account class. And inside of the savings account class, they have a lot of what do they call it? Student code sections that we need to implement. 1, 2, 3, 4, 5, and I think that's it. Oh, 6, the toString method here at the bottom. All right. All right, fair enough. Well, how do we go about doing that? I'm glad you asked. Let's go into our handy dandy GMC virtual desktop. And the first thing that we need is these files, the Chapter 10 Programming Activity 1 files. And for this, please log into, just type this address in directly into Chrome inside of the virtual desktop. All right, go ahead and log in to the classroom inside the virtual desktop. And let's scroll down to where here, course files. Go ahead and click on this, and you'll see a zip file. Go ahead and click on the zip file. That's going to download it. Bada boom, bada bing, and we will see all of the chapters, at least that we're covering here in CIS-211. We are interested in Chapter 10, Programming Activity 1, right? And here are the files that we need. All right, so we have the files. Let's minimize this. Let's minimize this. And go ahead and use this, NetBeans 8.2, please. Do not use this one. This one is not set up for JavaFX. So go ahead and double click here on NetBeans 8.2, and you should see something that looks like this. And you can verify you have the proper version of NetBeans in the virtual desktop right here, 8.2. All right. Once we have this, well, we need to create a new project, right? File, new project. For any new, any programming that we need to do, we're always going to do that. File, new project, select Java, Java application. Go ahead and click on next. Let's give it a nice descriptive name, like CIS-211 discussion. Go ahead and uncheck this. Uncheck this. Don't change the project location, please. It's a folder that you have read and write privileges to, and NetBeans will not get confused. So that all looks good. We're going to go ahead and click on Finish, and we will see that, yes, we do have an empty project here, and that's exactly what we want. The next thing we want to do is go here in the File Explorer, and let's go ahead and select all of these files that we just found under Chapter 10, Programming Activity 1, right? And the Textbook Activity Frameworks file. And let's drag, hold the left mouse button down, and let's release the left mouse button on side of default package. And you should see something that looks like this. All right, why do we see errors? Dun dun dun. Oh, yeah, I'll bet I know. Remember that it wants us to complete savings account, right? So if we look at savings account, well, there's all sorts of undefined stuff because we haven't put anything in there yet. So yeah, this particular project is not just going to compile and work um, out of the box, let's say. So for sure, we need to implement all of these missing pieces here before we can even see it run and do anything. All right. Um, all right. So how do we go about doing that? Well, before this webinar, I basically did exactly that, imported all these files, and I want to show you at least one potential solution. All right, one potential solution. I basically just created the, in fact, let me rename this real quick. Name this to week 2, just so we don't get confused. Week 2 discussion. All right, so I went ahead and I did exactly what I just showed you, created a new project and then added those files. But in savings account, I went in and added the missing pieces. All right, so let's at least understand why this is one possible solution. All right, if you found another and it still meets the requirements and the program still runs as intended, well, then you found another solution. Great job. Okay. All right. Step 1 here. Indicate that savings account inherits from bank account. Well, that's why we had to add this, right? Remember that the extends keyword allows us to inherit from a parent or a base class. In this case, the parent or base class is called bank account, and bank account is here, right? Public class bank account. So this is the parent or the base class. It has some good information in it that we might need in savings account, right? It has balance. It has uh, ability to deposit or withdraw money, right, from that balance. It has the ability to retrieve the balance or get the balance, and as well as a two-string method. If we say print the bank account object, uh, it's going to call this two-string method and give us a nice friendly string that represents what is inside of this bank account object. All right, so savings account extends that bank account class. So we are inheriting from the bank account class. And then number 2 says we'll define the private interest rate variable as a double that represents an annual rate. All right. Remember that principles of encapsulation say always make your member variables or member instance variables private. So that's why I defined this interest rate, right? That's what it wanted us to define as a double, but it should also be private so that nobody outside of this class can just start coming in and changing the interest rate. Can we change the interest rate then from outside this class? Yeah, that's what this guy is down here. Get interest rate, set interest rate. This is the accessor. This is the mutator for interest rate. This is the proper way, right? Using accessors and mutators in order to change your member variables. You don't just want to make this guy up here public and then anybody can set it to whatever they want. Everybody has to go through this get interest rate if they want to see it. Everybody has to call set interest rate if they want to set it. And notice, by doing these accessor and mutators, we can do input validation before we ever actually try to set the interest rate to a particular value. We can at least make sure that the interest rate is greater than or equal to 0, right? That's pretty important, especially if you're the bank uh, that implements the savings account. If somebody implements a negative interest rate, now all of a sudden you start taking away money, right? Instead of adding interest to the customer's account. Uh, they're not going to be happy. So for sure, they added some input validation here and said, well, yeah, you can set the interest rate, but make sure it's uh, greater than or equal to 0. Uh, we don't want to have upset customers, right, where we're charging them for their savings money. All right, so so we talked about this. That's why we created this as private. The next piece is number 3 here, write a default constructor. Okay, anytime we have a constructor, it needs to be the same name as the class. And so that's why we see them use the method name savings account, number 1. Number 2, the default constructor does not have any parameters. So that is how we know that this is a default constructor. There is no parameters. Now, the implementation of it, well, first things first is we have to call the parents constructor. And the way we do this in Java, and I even think C++, is you use the super keyword. And this super keyword is going to go and say, okay, let me see who my parent is. It's bank account. Okay, let me call bank accounts constructor. And this is, so when you see that super here, it is calling the bank accounts default constructor. All right, and that's very typical for any Java code that you see that extends a particular base class. Yeah, you're going to see it call super, and also you're going to see it call the parents constructor using super, and that has to be done in the very first line of your constructor, of your specialization class constructor. You can't move super to the bottom. And I think even the compiler will freak out. Or at least some languages it does. Let's see here. Yeah. It's like, sorry, why are you trying to call your parent's constructor at the end of your constructor? That is illogical, as Spock would say. That is illogical. So you can call the parent's constructor. It just needs to be done at the top of your specialization classes constructor. Set the interest rate, right? Set the interest rate to the default rate. Well, that's what we're doing here on line 26. Well, interest rate, which is this guy, is equal to default rate. Notice that because this is private, that means nobody outside of this class can use it or see it. But if you're a method inside of the class, you are able to access it directly and change it. Because the thought process is, well, if you're inside of the class, you should know what you're doing with all the private member variables. So this private only applies outside of the class. Inside of the class, we still have access to it, and we can use it. And then here just, it tells us to print a message indicating that this constructor is called. So that's what this line of code does here, is that we print a message saying, hey, we're inside the savings account default constructor. So that meets requirements for number 3. Number 4, overloaded constructor. Well, number 1, we know it's a constructor because, yeah, it's a savings account. Savings account is the same name as the class, so we know it's a constructor. How do we know it's an overloaded constructor? Well, here we go. There's 2 parameters that are being passed to it, and just because this has parameters, it's a constructor with parameters, it is known as an overloaded constructor. So for sure, this is the proper way. How do we know what parameters to pass to it? Well, it tells us down here. Make sure you pass a parameter called balance. That is a, does it tell us what? Starting balance. I guess it's implied that it's a double. I mean, balance does have a decimal point in it, so yeah, that would be a good thing. And an interest rate, and I guess it's implied that interest rate is also a double, and we kind of see that up here with the default rate. And here as well, double. So we have to kind of put 2 and 2 together as far as what the data type is for each one of these parameters. Now, what do we do once we're inside of the overloaded constructor? Well, for sure, we got to call the parent constructor, right? The bank account constructor using super. But notice that here even, we're not using the default parent constructor because we know that that has no parameters. we are, it looks like, using the bank accounts overloaded constructor that actually takes a balance, right? Here's the bank account constructor that takes balance. Here's where we're actually using the bank account constructor with the parameter balance. All right. So we're using an overloaded constructor even in the parent class. And do you have to? No, you could probably just as easy use the default constructor, but if you do that, you're going to have to set the balance somewhere else. All right, so we call the parents overloaded constructor to set the balance. And then we call set interest rate. Now the question is, was set interest rate in this class or the parent class? Aha, I'm glad you asked. Let's dig in a little bit. It looks like it is an internal method that we can use. And it does a little bit of input validation on the interest rate. All right, so we're going to set the interest rate to interest rate. Well, where the heck is this interest rate coming from? Aha, it's coming from this parameter up here that was passed in the savings account. All right, and then at the bottom it says, well, print a message indicating that this constructor is called, and that's why you see the statement here. Hey, we're inside the savings account overloaded. In fact, I should say constructor here. Okay, so constructors are basically responsible for just setting up your member variables to a particular value. That's what constructors do. They just initialize everything. The default constructor initializes it to a default rate. This overloaded constructor initializes the interest rate to whatever is passed in, not the default rate. All right, so that's number 4. Number 5, apply interest. All right, so it depends on the bank how often they apply interest, but the idea here is that we have a method called apply interest that when it's called is going to take whatever the balance is inside of our bank account and multiply it by the interest rate divided by 12. Right, so this is annual interest rate is what we're assigning up here. Annual interest rate. So we're dividing by 12. So apparently, I guess we call this once a month. Yep, passing a month's worth of interest. So that's why we're dividing by 12 here. And in fact, a better name for this probably would be apply monthly interest, right? Not just apply interest. And that would at least explain a little bit why we're doing divided by 12. So we're going to grab the balance. We're going to multiply it by the monthly interest rate. Whatever that value is, okay, it's going to do this math first. It's going to replace all this with whatever the real number is that comes back with this math, and then it's going to call deposit with that number. Well, the question is, well, what the heck does deposit do? Well, I'm glad you asked. Let's look for the deposit method inside of savings account. Uh-oh, I don't see it. Well, how in the heck are we calling deposit when I don't see any deposit method listed anywhere? Oh yeah, this has a base class called bank account, and if we look inside a bank account, right, extends bank account, we do see, oh yeah, here is a method called deposit that's going to enable us to pass an amount as a parameter that is a double, so it has a decimal point in it, and as long as that's greater than 0, well then go ahead and add it to the original balance. And remember that balance is part of the base class, right? Every account has a balance, right? That's the beauty of this object-oriented design is that, well, you might have a savings account, you might have a checking account, you might have a stock and bonds account, but at the end of the day, all of these are bank accounts that have a balance. All right. So this deposit guy here, we can use inheritance. We can use the base class to call deposit and make changes to the balance. All right. And then at the end of the day, they're a little bit, and I don't remember if they call this out as a savings account return type. Let me just look here real quick. Let's see if they at least gave us, which one are we on? We are on apply interest. Yeah, they don't return, oh, a reference to this object. They do tell us, all right, so a reference to this object, return a reference to this object. Well, this object is a savings account, right? This object is from the class called savings account. So that's why the return type for apply interest is the actual savings account object itself. Unique design, I'm not sure why they did that here. I don't even think that's really necessary, but apparently whoever is using the savings account class wants us to do this. And I would have to look at the design of all these other classes to know why. I would think apply interest could, I don't know, return the current balance, or apply interest could even be a void return type because you're updating the balance here, right? I don't know why they have us returning the savings account, but for sure if you don't do this, it's not going to compile or run. So this part here is a little bit confusing unless you got a good background in object-oriented design to understand what the heck this means. All right, but at the end of the day, it means return a savings account when you're done. And the savings account is the this keyword. This basically means return the object that this is part of, which is a savings account. So this is a little bit, I guess, advanced or strange design, but we won't talk about that. All right, and then finally, number 6 is toString. Wants us to create a string that has the balance and the interest rate as a decimal format object that looks like this. All right, so for sure, we needed to create this decimal format line that is going to set us up for success with this string formatter, 0.00%. And then we want to return a string that we're getting what it's going to do is it's going to look at the parent, right? The bank account, super is the guy you inherited from, or bank account, and use its toString method first. And this toString is going to at least let us know what the balance is inside of the bank account. Then once it returns this as a string, we're going to add that. We're going to add our interest rate information after we see the balance information. In fact, I don't know why I put that on. All right, so take whatever the bank accounts information is and add it to, add the interest rate information from the savings account to the same string. And when you do that, don't forget you need to declare the return type as a string as well. And if we do all of this, and again, this is one solution, this is not the only solution. When we run it, how do we know we have a solution? Well, when we run it, and again, we're working on this one here. When we run it, all right, it'll ask you, it'll basically give you this dialogue. Let's say we deposit at $100. Interest rate, sure. Let's say 3% annual interest rate. We should see something that looks like this. And when we click on each one of these buttons, it should produce some results that make sense. So if we change the interest rate to, let's say, 4% instead, and we hit OK, well then, yeah, we see a new line here that lets us know we changed to 4%. So that looks good. If we apply interest, or at least monthly interest, well, it's going to take that 4% times 100, and I guess that equals $100.33, right? And I suppose we could do that multiple times. If we hit deposit, right, each one of these buttons is calling each one of apply interest, right? Set interest, uh, each one of these buttons is calling some code that we just implemented. And how do we know we have a solution? Well, we test all of these buttons and we make sure that the output looks good, right? Just because it compiles and runs doesn't, I mean, we could still have a bug in the code. So for sure we need to test, right, each one of these buttons and make sure that it's doing what we expect and our logic is correct. So at a minimum, if I'm QA and I'm looking at this application, 1, 2, 3, 4, 5 tests at a minimum that I need to report. Um, and so far, so good. Balance is 151.34. Interest rate is 4%. Yeah, it looks to be a good solution, at least with the test values that I just used there. So in industry, how do you know you're done? Well, you run the program and you make sure that you meet all the requirements, that um, everything looks good, and that's what I just did there. So that is one possible solution for your discussion this week. Uh, Hope make your best effort at it. Feel free to implement at least this one if you like, or as long as you understand this code that we just went over here, post about it, talk about it. Um, I'd love to hear your thoughts. All right. So that is the programming activity for your discussion of week 2, at least one possible solution. All right. What else are we supposed to do here in week 2? Ah, yes, your programming assignment. So your programming assignment, now we're finally getting into object-oriented design here. And notice that it, it wants us to create a few different classes. One is an abstract or a base class that is abstract called auto. And this auto abstract class should have these three, 1, 2, 3 member variables that are private, and should have these 1, 2, 3, 4, 5, 6, 7, 8 methods that are public inside of this class called auto that is abstract. All right. Why is it abstract? There is a method called print stats that is abstract, and we're not supposed to implement this. We're only supposed to call it out as abstract. All right. So that's the first requirement. Second requirement is, all right, create a specialization class called truck that basically inherits from the auto class, that extends the auto class, and it should look, well, obviously truck is a specialization class of auto, so truck has all of this stuff in it, but we're also adding a new member variable. Well, what makes it a truck? Well, maybe it has horsepower. And so we created that. It wants us to create this new member variable called horsepower that is an integer for whatever weird reason. And this truck class has these two methods. Number one, an overloaded constructor. How do we know it's overloaded? Because it takes these 4 parameters. And number two, that abstract method called print stats. Yeah, well, we need to implement it. Otherwise, we can't, the auto class, our base class, forces us to implement this print stats. Okay. And then third part is, oh yeah, create another class called car that extends the auto class as well. But notice that car calls out the number of doors instead of horsepower. And so we need a new private member variable. That's an integer called number of doors. And an overloaded constructor that takes these 3 parameters. And we need to implement that abstract print stats method as well. All right. Oh yeah, and then part 4, they probably should have put a number 4 here. You need to create one more class called auto test. All right, that's going to have this, and actually there is a typo here that I need. I'm going to update this after the webinar, and I'll show you what I'm talking about here in just a second. All right, so the idea is that we run this code here with these other 3 classes that are called out up above. And when we run that code, we should see that is output. And notice that this code is using polymorphism, right? We're creating a new car, we're creating a new truck, we're adding it to this auto list that is just a bunch of auto objects, and we're able to cycle through all of those auto objects using this enhanced for loop and just call print stats. We don't care if it's a car or a truck because the car and truck also has already implemented print stats. So this is a very good way to practice how we create base classes that are abstract, and we implement their abstract methods, and then we create several of those specialization classes, and we add them to a list, and we use polymorphism to call whatever that abstract method is that's been implemented. All right. Yeah, for sure in game development now, you you get into a lot of this. All right. And even in industry developing commercial apps, you also use a lot of these object-oriented methodologies. All right. Okay, so how do we go about doing this? Aha, I'm glad you asked. Let's go to our nice, wonderful remote desktop. Let's create a new project using NetBeans 8.2. Let's select Java, Java application. Let's give it a nice descriptive name. Oh, I guess this is 23, not 22. What is it? CIS-211, week 2 assignment, right? Leave that as is, leave this unchecked. For the create main class, yeah, let's go ahead and create the main class. And the main class in this instance for this assignment is going to be auto test, right? Because this goes in main. So for sure, auto test is our main class. So I'm going to call it here, create main class. I'm going to blow away all of this and say, no, I want my main class to be called auto test, right? Main class called auto test. And okay, looks good. Uncheck, leave, descriptive name, click on finish, and bada boom, bada bing. We have a new project that has a new auto test file / class that has a main method in it. And man, that is exciting. All right, then what? Well, then if it were me, I would come in here and I would copy and paste at least the code they give us here into main, and we're going to see all sorts of issues. All right, let's indent it properly, right? For full credit, make sure that everything in between these curly brackets is indented at least another like 4 spaces so that it's easy to see what is inside of main. All right, why is it yelling at us? Couple of reasons. But before we talk about that, oh yeah, these stupid quotation marks. I wish that for some reason in the classroom when they use quotation marks, it's not the quotation marks that the Java compiler, interpreter, whatever you want to call it, likes. So for sure, change these quotation marks. And I think there's one other. All right, before I go there, let's leave this as is, and we'll talk about these errors in a little bit. High level, we've got the auto test class. That's good. But notice that we also need an auto class. We also need a truck class. We also need a car class. So let's do that. Let's come over here. Let's right click on default package and say new Java class. For sure we need one called auto. Let's go ahead and click on finish here. All right. Here's our auto class. For sure we need one called car. Okay, looks good. Click on finish. There is our class called car, and we need another one called truck. This all comes from the requirements. Okay, so now we've got all, I'm going to go ahead and hit save all. So we've got the auto test class with main and the code that's needed there. We've got an auto class called auto, another class called car, and another class called truck. And so what I did was exactly what I just showed you here. Created a new project, added these four classes, added the code from the program assignment description, and I came up with some guidance for you. All right, so let me go ahead and close this guy and open up the guidance solution. Did exactly what I just showed you. But I did make, all right, let's talk about this guy first. This is the base abstract class, right? It tells us we want an abstract class called auto that contains these things. So remember that public class auto. Well, we got to modify it a little bit and add that abstract keyword for sure. The other thing, the other guidance I want to provide is, yeah, for your member variables, typically in industry, we declare them here at the top, and you need to make sure that they are private, because I think they calls it out here. Yeah, make sure they're private. Here are the methods that are called out. The constructor, this is actually an overloaded constructor that takes these three parameters. You should utilize these three parameters and initialize these guys with them right in here. That's why I say initialize member variables here. It also says we need a get brand name, set brand name. All right, here's get brand name, here's set brand name. Get brand name should return a string because that's going to be the value that's inside of brand name. Whatever brand name has been set to, you want to return that here. All right, so some of these are just placeholders. Like this null is just a placeholder. My guidance is here as far as what you should do with this placeholder. Same with set brand name. Well, what does set brand name do? It takes whatever's in this name parameter, and we want to set our brand name member variable to whatever's passed in as the name. Void return type, right? Because there's no need to return anything. We're just setting the brand name inside of this object, right? We're not getting anything, so that's why that's void. Get miles, set miles. Well, if you get the miles per gallon, make sure you return the member variable that has miles per gallon in it here. If you set the miles per gallon, we'll take whatever was passed in here, this mile per gallon guy, and set your member variable equal to that value, whatever's passed in. So lots of accessors and mutators here, right? This is the accessor and mutator for color. If you want to get the color, we'll make sure you've turned the string that is the member variable called color. If you want to set it, you use this, and you have to update whatever this code is here in order to set the member variable color. And then lastly, they do tell us that you need to implement an abstract method called print stats. Because it's abstract, we need to use the keyword abstract in front of it, and we don't want any curly brackets, we just want a semicolon. All right, because this is an abstract method, we use the keyword abstract, and we use a semicolon after it, not the curly brackets. All right, and anytime you see an abstract method anywhere in this class, you need to make sure that the class that it's declared in is also abstract at the top, and you'll know it'll freak out and give you a compiler error if you don't do that. All right, so this is guidance for the auto. What else? Here is guidance for car, and again, please include a nice descriptive header at the top with your name in it and which file this is. that is good practice, especially for industry. We want our code to look nice and have descriptive information in it. All right, this class called car, which is called out here. I'm sorry, here. Looks like we're supposed to add a new member variable called number of doors, as well as a constructor and that print stats method. So that's why I'm giving guidance for you to do that up here at the top of the class. Here is the constructor that it calls out in the requirements that we pass these 1, 2, 3, 4 parameters. I suggest, remember, using the base class constructor at the top and use some of that information that you were passed in. Use that with your base class constructor, right? As long as you have this guy defined, well, then go ahead and use it in your car class in order to set that information inside of the auto base class. All right. Here, you want to initialize number of doors. Down here, number of doors exists here, not in the base class. So, yeah, I would probably set number of doors equal to this number of doors here. Okay. Print stats. Notice that this is the abstract method that's called out here, but because this is a specialization class, you don't put the abstract keyword here because you're implementing the abstract method. So when you implement an abstract method, you want to put @ override at the top, at least for Java, and you want to use what it looks like exactly, string print stats. All right, string print stats. And inside of here, you want to implement the logic that's going to return a nice friendly string that represents the car data, and it should look like this. Right? Car brand, Corvette, assuming that it's a Corvette. Somebody put in Corvette. Oh, well, it will be Corvette because our auto test passes in Corvette. And then it's got basically all of the 1, 2, 3, 4 fields that we passed in here. We need to create a nice friendly string here that looks like this, and then pass it back here. Okay. That is the car class. The truck class, well, that's here, very similar to the car class, but here we're declaring horsepower, right, instead of, I think, car's number of doors. And we're declaring an overloaded constructor with these 4 parameters instead. Let me see here, oh, well, here, this should actually be horsepower, not number of doors. Right? That should be horsepower. And here you're going to initialize this guy's horsepower, the member variable horsepower, to whatever horsepower was passed in to the constructor here. All right. And if you don't want masking issues, feel free to rename your local variable here, your local parameters, so that it doesn't conflict with the member variable called horsepower. Especially when you're new to programming. You're going to see a lot of, when you start using the same variable names here and as the parameter or inside of your function, it's going to get real confusing which variable is being used and when. So as long as you're always giving your variables a brand new unique name, that's not used anywhere else, then you don't have to worry about any of those masking issues anymore. Okay. What else? Okay, so this is the constructor. Take these 4 parameters, pass 3 of them to the auto constructor, right, with these 3 pieces of information. And in this last piece of information, new horsepower, well, you want to initialize your member variable to this new horsepower guy. Print stats, right? Because truck is extending auto, because truck is a specialization class of auto, we have to implement print stats. And this print stats is a little, the definition is the same, just like here in car, override, string, print stats, but the string should look like this and actually have the word truck in it, right? And actually have HP or horsepower instead of number of doors like car has. So notice how this print stats abstract method is enabling us to create a unique string for each one of these different auto types. Very similar to that, what was it, draw method that the book presents, right? Every unique figure like shape, square, has a unique draw method. Well, here, every unique auto, like car and truck, has a unique string that represents it. All right. So there's my guidance for auto, car, truck. Oh yeah, auto test. So this is the code that they gave us here. But the problem is here, I think I had to make some changes. Yeah, make sure that you put in auto in front of auto list. Just use this code here. This code here, I made a couple of minor modifications. I believe auto wasn't here. I also don't believe the parentheses, yeah, are listed here. So I'm going to update that here in just a second. This is the code that you want to use. Don't change this code. Don't change this code because when we run this, we'd expect a new car that's a Corvette with these parameters to be created. We'd expect a new truck with these parameters to be created. And when we hit this for loop, well, we should see output that looks like this here. And this is in your print stats method. This is in print stats for the car. This is in print stats for the truck, and it's using polymorphism to go through all of these objects in the array list and call that abstract method called print stats. All right. So when you run this at the end of the day, if I run it right now, we are going to see probably nothing. Call print stats. I mean, just let's see if this is even system. All right. If we run it right now, we are going to see, yeah, just the test statement at the bottom. Once you've implemented everything correctly here, here, and here, you should see this. This is what I'm going to look for in order to issue full credit, as well as the proper way to implement all the guidance here. I do expect that you can take this guidance and convert it into Java code. Okay. All right. So that is your guidance for the week 2 programming assignment. If you need further help, obviously reach out to me via email and let me know what questions you have, and I'll see if I can give you guidance without giving you a solution, so that hopefully eventually we get to the actual solution. What else? What else? What else? Oh, right, the quiz. Obviously, at the end of every week, we have a quiz. I think it's 10 questions, 4 open response, 25 minutes, 1 attempt at the quiz. So for sure, make sure that you are you've studied chapter 10 and are well prepared before taking the week 2 quiz. Oh, one final point: the results document. Let's talk about that because I'm still getting some questions concerning that, especially because our current solution here has 4 files, not 1, right? So what I would like to see is something like this. Obviously, I use Word, and you want to put your basic information at the, all right, am I going to go, what class you're in, what's your name at the top, date, what assignment this is, all right? Obviously, you want to fill in all of that. Now, because we have 4 files, I want you to list the names, right? We got autotest.java, all right? I'm going to say file name. We have, what's the other one? Car.java. We have truck.java. What else are we missing? Oh, auto. File name, auto.java. And what I want you to do, and don't forget, yeah, fill this in, please. All right, with whatever your appropriate information is. Here, autotest.java. Please go into NetBeans, go into autotest, do Control A, Control C, or right click, hit copy, whatever, right? And then, so we are literally copying and pasting. Please don't provide a screenshot here. For the code part, copy and paste the code directly into the Word document, please. For each one of these, car.java. I'm going to go here into NetBeans. Here is car.java. Okay. Here is truck.java. Here is truck.java. And finally, auto.java. So come in here, Control A, Control C. I don't want a million screenshots for the code. All right. Copy and paste all of your code into here. All right. And at the very bottom is the screenshots, right? And when you take, well, I guess for this, the screenshots are pretty easy. Screenshots of program, let's say running. And at least for this application, we have a very specific main function that is running a very specific test. So yeah, you just want to run this auto test guy and take a screenshot of this output here, right? I would say go ahead and do the entire screen because the timestamp is down here, and I do want to see the timestamp. Take a screenshot of this. So I don't know, what's it called? Snippety snip snip. Let's do a new full screen snip. Ba-boom. Here it is. Let's hit copy. And let's go back to our Word document and let's hit paste. Now, eventually you are going to get in, your assignments are going to have some applications where several different inputs are possible and several different outputs are possible. And under those cases, you're going to want multiple screenshots of the program running using different input, displaying different output. In this case here, the way I'm basically looking for this very specific output here to know that, and I'm going to look at the code too. I'm going to look at the architecture. But at the end of the day, this is what I'm looking for concerning the output. So when I look here, I would expect to see those, right? This output right here. All right. And then I'm going to look back up here at the code and go, okay, did they implement everything correctly for all of these different classes and methods? And so super fun stuff. And then, yeah, okay, once you have that, please save it. I think the best way to save it is under your project folder. What did I call this? 23SP CIS-211. Oh my God, I got so many projects. Please hold. What is it? Week 2 assignment. Yes. And I would say create a new results folder inside of there. And inside of here, maybe use your initials, week 2 assignment, whatever you want to call it, and go ahead and hit save. And the reason I say that is because when you submit, what I would like to see, go into File Explorer, go into NetBeans Projects, find your folder again, wherever the heck it went. I think it is week 2 assignment. Okay, go into your project folder, go into the source folder here, grab all of these files, copy them, go back one, and inside the results folder, go ahead and paste all of those Java files. All right, so you've got your results document, you've got all your Java files, highlight all of them, right click, say send to, say compress zip folder, give it a name, just week 2. All right, JLSB week 2 programming. I don't know, something like that, right? This is what I want you to submit. This is a zip file that contains everything I want inside of it. All right. So please submit this one zip file. And ultimately, hopefully, I just look at this Word document. It has everything I need in it, and I'm happy. I open up one file, I see everything, and I'm good. If for whatever weird reason I have questions concerning the code that's in this document, then I'm going to import these Java files into NetBeans, and I'm going to look at it that way. So the Java files are just kind of if I need to, if I have to fall back and look at the original code. All right. So, whew, yeah, that's it, right? That is it for week 2. I basically, uh, I hope you continue to find these weekly webinar videos useful. Please comment, like, uh, do send me an email, whatever. Continue to provide me feedback. That is definitely what helps make them better. And yeah, reach out if you need anything at all. Okay? So have a great rest of your week.